So today we're doing indicator 28.2, and today we're going to do it a little bit different. We're going to determine models using difference and ratios, which that doesn't mean anything to you right now, but it will be by the end of the hour, meaning we're not going to be given equations. We're going to have to figure out if these are linear, quadratic, or exponential based on these difference and ratio tests, and we're going to talk about how to do those here in just a second. But first I want to talk about the definition of just what does difference and ratio mean, because you kind of got to know that to be able to use them. So difference is adding and subtracting. Ratio is multiplying and dividing. Make sure you get that down. Is it called what? No, it was determining models based on ratio and difference and ratio. I'll slide back up to the title here in a second. Difference is adding and subtracting. Ratio is multiplying and dividing. And you can kind of add to that, and it won't make sense yet, but it will. Difference is going to be dealing with linear and quadratic. Ratio is going to be dealing with exponential. And that should kind of make sense to you, because when we were doing our exponential t-charts, remember we kind of started noticing the pattern of every time it tripled or every time it doubled or every time it quadrupled. That's multiplying and dividing. Okay? It multiplies rapidly or exponentially. All right, and I'll go back to the title. Xander. There's the title again if you need it. All right, so I'm going to show you how to tell just by looking at a t-chart if it is linear, quadratic, and exponential. And it's these little tests that we run it through. And one of them, we're going to start with difference, and then we're going to go to ratio. So I want you to start out by doing the linear example, but don't worry about the orange parts yet. Just do the XYT chart in your notes. And then I'll talk about what the orange parts mean. All right, so we have an XY table. This is just a set of points, okay, given to us in a table. You can see that the X's change by +1 every time. So each step from point to point, right, from this point to this point to this point, it increases by 1. That's fine to kind of note, but you're really not going to be messing with that in the assignment. What we care about is the Y's. That's the important one. The Y's are what's going to tell us whether or not it is linear, quadratic, or exponential. So if you think about a number line, okay, so we've got a very straight number line there. All right, to go from -1 to 2 is going in a positive direction, 1, 2, 3. So that's +3. Now, when you're going from negatives to positive and positives to negatives, sometimes you do have to think about the number line. Obviously, going from 2 to 5, you should be able to tell that's just a +3. Going from 5 to 8, that's a +3. This is called a first difference. If you match after checking your first difference, it's linear. You're done. You can stop. You can label it as linear and move on. And if you think about what is unique about a linear equation, it's the slope or the rise over run, and it's the fact that it's constant. So in this case, you don't have to do this in this assignment, but you will going forward. The slope here would be your change in y's, which would be +3, over your change in x's, which would be +1. So the slope here is 3 over 1, or 3. And that's why it's linear. It's because it's a constant, never changing, up 3 over 1, up 3 over 1, up 3 over 1. It's never going to bend. It's never going to turn back toward itself. It's always going to stay straight, okay? And that's what makes it linear, is that first difference change being constant. Now, I want you to put this example in your notes of quadratic, and I'll move it over here in a second, but I'm purposely blocking off that side right now. And again, we're going to think about our number line. And we're going to have -1, 0, 1, 2, 3. All right. So if you think about the first difference, we want to look and see the addition subtraction, right? Where first we're looking at differences, that's adding and subtracting. We want to know how many jumps does it take to go from +1 to -2. Well, +1 to -2 is a -2. It's a backwards jump. So you would put -2 as that first difference jump. I'll just ignore that step out to the side. And then if you look at the jump from -1 back to +1, that's a +2 jump. And then from 1 to 7 is a 6, and from 7 to 17 is a difference of 10. So, do we match in first difference? No. So this is not going to be linear. So we have to move on to second difference. I'm going to do the same thing now between my first difference numbers. I'm going to now check the second difference. So what is the difference between -2 and +2? Well, if you're on the number line and you go from -2 to +2, that's a 1, 2, 3, 4. That's a +4 jump. Then if you go from, right, this was this jump right here, that's +4. Then you go from 2 to 6, that's also +4. From 6 to 10, that's also +4. Now you match in second difference. That means it's quadratic, and you can stop. So linear and quadratic, it's always going to be addition and subtraction. And if your first difference lines up, it's linear. If your second difference lines up, it's quadratic. Now let's look at exponential. So here's the T-chart for exponential, and then we'll talk about checking differences first. All right, when I check my differences, because that's the first thing I want to check, right? To go from 0.25 to 0.5 is a difference of 0.25. To go from 0.5 to 1 is a difference of 0.5. And to go from 1 to 2 is a difference of 1. Plus, plus, plus. I don't line up first difference, so that should tell me it's definitely not linear. Now I need to check quadratic. So I need to check second difference. And I'm kind of running out of room here because I'm going to be writing over the real answer, but ignore that real answer for a second. So now I'm going to check second difference, and I'm going to look at the difference between 0.5 or 0.25 and 0.5, which is 0.25. Then I'm going to check the difference between 0.5 and 0.1, and that's 0.5. And if you're not sure how to check the difference, just subtract 1 minus 0.5, and it's going to tell you the difference. Okay? I don't line up in second difference either, which means it's also not quadratic, which only leaves exponential, but you still have to tell me the multiplier, so you still have to work it out. You need to look at the numbers and decide how much do they multiply or divide every time, right? They don't jump by pluses and minuses. We've already determined that because we checked the differences. But if you take 0.25, what would you have to multiply that by to get to 0.5? The answer is 2. Then look and see if you multiply 0.5 times 2, do you get 1? If you multiply 1 times 2, do you get 2? And the way to check that in your calculator is if you put 0.25 times 2 equals, you get 0.5. Then just simply hit times 2 again and see if you get the 1. Then hit times 2 again and see if you get the 2. Okay? The other way to check it is you could do it by division. You could divide 2 divided by 1. Right? 2 divided by 1 is going to give you 2. 1 divided by 0.5 is going to give you 2. 0.5. So you can do it either up or down. It doesn't matter which way you check it. But you need to check and see if there's a multiplier. If first and second difference don't work, you know it has to be exponential. So the main thing you have to do here is just find your multiplier. Or if you start out with high numbers and go low, it's going to be a divided by, right? Because you get smaller as you go. But you're either going to multiply and get bigger by the same number, or you're going to divide by and get smaller by the same number every time. So you might see it look like, I'll just kind of stick it up here, and I don't care if you put this in your notes or not, but you could have something that looks like this, where you're 9, 3, 1, 1/3, 1/9, right? So let's say this is your T-chart. Well, you start out high. How do you get from 9 to 3? You divide by 3. How do you get from 3 to 1? You divide by 3. How do you get to 1/3? You divide by 3. 1/9, you divide by 3. So if you start big and go little, it's going to be division. If you start little and go big, it's going to be a multiplier. Does that make sense? All right, these you do not have to put in your notes. I just want to run through a couple of examples with you. Okay? So first I'm going to check my differences. To go from 1 backwards to 0 is a -1. To go from 0 to 3 is a +3. 3 to 10 is a +7. 10 to 21 is a +11. 21 to 36 is a +15. And 36 to 55 is a +19. First difference doesn't work, so we're definitely not linear. Let's check second difference. To go from -1 up to +3 is a +4 move. Then you can see all the other ones. 3 to 7, 7 to 11, 11 to 15, and 15 to 19. I check off at second difference, which means my answer is quadratic. You need to show all of this work plus write the word quadratic. Okay? Now let's look at this one. I can check differences. If it doesn't jump out at you, check them. From 4 to 12 is +8. I went blank there for a second. From 12 to 36 is plus, my pen just died. There we go. Sorry, my pen died. +24. Somebody help me out. What's 108 minus 36? And then my next one. All right, so first difference definitely doesn't work. 8 to 24 is 16. I can already tell you 24 to 72 is not 16. So stop here. It's obviously not first difference. It's obviously not second difference. So let's try our multipliers. How do we find it? So very, very easy. I'm getting bigger, so it means multiplication, right? My numbers are getting bigger, so I know it's going to be multiply. What times 4 gives me 12? And then check it all the way down. Does 12 times 3 equal 36? Whoops. Times 3 equal 108? Yep. Times 3 equal 324. There's your multiplier. It's a ratio, which means it's exponential. Okay, last one. Let's check it. -4 up to -3 is a +3. Then up to +2 is another +3. 2 to 5. 5 to 8, linear. Okay, but the work that I showed here is the work if it says on your packet, and you've got to, and we're going to go over this here in a second when I give you your packet. You've got to read the directions for each section very carefully. Some say use difference and ratio. If it says in the directions to use difference and ratio, it means I want to see this. Now, what if it says use difference and ratio, but it gives it to you like this? How do I use difference and ratio if it's given to me like this? Yeah, put it into a table. My first point is -1, 1/9. My next point is 0, 1/3. My next point is 1, 1, 2, 3, 3, 9, 4, 27. What's happening every time? Yeah, it's times 3. Times 3. If the pattern jumps out at you and you don't have to check first and second difference because you can see there's a multiplier, you don't have to show first and second difference and then erase it and then do this. Just start here if it jumps out at you that blatantly. This was obvious, 1/9 to 1/3 to 1 to 3 to 9 to 27. It obviously jumped by times 3 every time. So just show me that times 3 and then write exponential. Good? All right, let me stop the recording. For those of you at home, click load on Cami. And then there's some special instructions because you will need graph paper for some of this assignment. And there are instructions on Canvas as to how to add graph paper to your assignment. Email me if you have any questions.